Hi, my name is Paula and I'm one of the tutors at Chegg. I'm going to be talking to you today about angle of depression and angle of elevation. These terms usually come up when you're starting to do trigonometry and you're learning some word problems with that. That'll be when you hear these terms, angle of depression, angle of elevation, students often confuse where to define them. For angle of elevation, we're talking about something that's at a lower point. So if we have maybe a person standing on the ground looking up at a building or walking up a staircase, you may say the angle of elevation of that staircase. And we're measuring how high up that angle goes. So that's starting from the ground or from whatever you've defined as your lower base, the horizontal line measured up. When you talk about angle of depression, it's from that higher point, and you can always compare within one word problem. You have both an angle of depression, angle of elevation. I'll talk about that in a minute. From the higher point that you're looking down. So that may be an airplane flying along looking down, like the example problem we'll do in a minute. The angle of depression is how far down you've gone relative to if you were looking straight ahead, that would be an angle of depression of 0. So now you start to look down, you've increased your angle. When you have an angle of depression, it is equal to the angle of elevation of what you're looking at. So if you're up in that airplane and you're looking down, if I were to extend this line all the way here, I'd have that this angle, if I label this as x here, is going to equal the angle of elevation from the ground. Because what I've done is I've made a horizontal line that's parallel to the ground or to whatever my lower defined basis is, and those are alternate interior angles. They're going to be equal. Most common mistake that students make is to think that angle of depression would be this one over here. And it is not equal to that. Sometimes it helps when you're doing angle of depression. Think about if you took your whole problem, turned it upside down, 180 degrees, turn it around. And now you can see that you have an angle of elevation, just that it's upside down. So let's go on to some word problems so I can make that a little more clear what I just explained. In this first problem, we're talking about angle of elevation. You are standing near the Washington Monument, which is 555 feet tall. The angle of elevation from your position to the top of the monument is 55 degrees. How far are you from the monument? So I'm going to draw what I have as my objects here. I have a tower, and I have the person that's standing over here, and they're both on the ground. So I have that the angle of elevation from your position, that's going up this way. Remember, if angle of elevation was 0, it would be flat with the ground. So I'm going to start measuring coming up from the ground. My angle of elevation is right there, 55 degrees. Now I have that the height of the tower is 555. So I can label over here that I have 555 feet as the height of the tower. Now I can use some trigonometry to solve this problem. And I can say that the tan of 55 degrees equals the opposite, the 555, over adjacent, which is the unknown I'm solving for. I want to know the distance from the person to that tower. So we're going to label this as x. 555 over x. If I rearrange my equation, I have that x equals 555 divided by the tan of 55. And if I, let me just fix that 3 there. And if I solve for that, then I get that it's 389 feet if I round to the nearest foot. So just filling this in. So my x is going to equal 389 feet. Okay? Make sure you always label your units when you're giving your final answer. Just to compare to the angle of depression with this elevation, say that I had a camera that was up on top of the Washington Monument, and that I want to angle it down. I need to know what angle of depression do I need to aim it at that person. The mistake would be to say that it's this angle. It is not, because your angle of depression is going to equal the angle of elevation from the other vantage point. So I'll draw a horizontal line going out along the ground here, and my angle of depression is coming down from that line. Because remember, if you were at the top of that tower looking straight out, that would be 0 angle of depression. As you start to look down, it increases that angle. So that would be 55 degrees. That's going to equal the angle of elevation from the ground. So just keep that in mind, how those two angles relate. Now let's look at a problem that actually does use angle of depression. A plane is traveling at a height of 40,000 feet above ground. The runway is 200,000 feet away from the plane's position as measured along the ground. At what angle of depression must the pilot look down to see the runway? So in this problem, I have an airplane. And there's a runway that's some distance away on the ground. So we'll just draw that like a building. And my ground comes out like this. I have the height of the plane, which is going to be straight down to the ground, what the height was. So there's my right angle for the triangle. And I need to know what's the angle of depression. So the common mistake, as I said before, would be if you draw this triangle right away and you think, well, here's the angle that's up by the plane, that must be my angle of depression. But it is not, because angle of depression is, if you were looking straight out, it would be 0. So now as you start to go down, that's your angle of depression. So what I'm trying to solve for is this x here. And remember, that's going to equal your angle of elevation from the lower object. So from the runway, the angle of elevation to look up at that plane would also be my unknown angle, my x degrees. Now I have some numbers here so I can plug in and solve. This is 40,000 feet. And I have that along the ground, it's 200,000 feet. Again, I can use a tangent ratio to solve for this and say that the tangent of my unknown x degrees equals 400,000 opposite over adjacent is 200,000. And if I now use an inverse tan function, if you haven't learned about inverse trig, don't worry about how to do that part, as long as you understand how I set up this ratio, that the inverse tangent of that big ratio there, the 40,000 over 200,000, is going to equal my unknown angle, x degrees. If I plug that into a calculator using degree mode, I will get that it's 11.31 degrees. Now, whenever you're solving problems involving angle of depression, angle of elevation, be very careful to label your angle in the correct spot, but also look at your final answer and make sure it's logical. So let's look back first at the example 1 where we had the angle of elevation. I had that the Washington Monument was 555 feet, and I'm standing such that the angle of elevation is 55 degrees. I like to think of it relative to if that angle had been 45 degrees, that would be a smaller angle. That would mean that it was further out, that it was over here. If you had 45 degrees in a right triangle, 45, 45, 90 triangle, you're going to have both legs are the same. So the 555, that's how far away I'd be standing if it were a 45-degree angle. As you move closer, you've increased the angle of elevation and you've decreased the distance. So it makes sense. It's a logical answer that I got 389 feet, which is less than 555, because 55 degrees is more than 45. I can use the same sort of logic looking at this plane example. And I have the plane that's 45,000 feet above ground, and the distance along the ground to the runway is 200,000 feet. That's a much bigger number than 40,000. So we have a really long triangle. 200,000 feet is very stretched out. And it should be much less than 45 degrees because that is so much more than 40,000 that my angle is going to be fairly small. So 11.3 degrees is a logical answer. It does make sense. So when you're solving problems involving angle of depression, angle of elevation, make sure you clearly label a diagram. Don't try to jump right into writing your ratios and your formulas without drawing a diagram. Always draw the picture. And remember that the angle of depression from the higher point is going to equal the angle of elevation from the lower one. Keep that in mind and it will stop you from making common mistakes. I hope this has helped clear up. If you need any additional help, feel free to contact me on Chegg. Thank you for watching my video.